Good morning, everyone. Hello. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Chemical Equilibrium from Chemistry. And in this session, we are going to learn about factors affecting the position of equilibrium. Factors affecting the position of equilibrium. So, for which type of reaction equilibrium is obtained or attained for a reversible reaction? For a reversible reaction. So let us take a reversible reaction. A gives rise to B. When can we say that this reversible reaction has attained equilibrium? Already we have studied that when rate of forward reaction is equal to rate of backward reaction. So this reversible reaction is in equilibrium. And this equilibrium position or equilibrium state of a reversible reaction is determined by some factors. So let us see that factors that determine the equilibrium state or equilibrium position. One, concentration of reactants or products, or we can say concentration of reactants and products. Second one is temperature. Third one is pressure. So these are the factors that determine the equilibrium state. Okay, if these factors are changed, now what is happening? Now this reaction is in equilibrium. The reversible reaction is in equilibrium. Okay. Now you are changing either concentration of reactant or product, or temperature or pressure, any of the factor. If you are changing, then what happens? This reversible reaction, its equilibrium position is disturbed. It will not be in equilibrium any further. So when you change these factors, what you have to understand, when you change these factors, the equilibrium is disturbed. Equilibrium is disturbing means that reaction will not be in equilibrium. Okay. Now, when you are disturbing this equilibrium position or equilibrium state, the tendency of a reversible reaction is to attain equilibrium. Again, it will behave or respond in such a way that again it acquire equilibrium. Okay. So what you are doing is you are disturbing the equilibrium. How you are disturbing the equilibrium? You are changing the factors that determine the equilibrium. What are those factors? A concentration of reactant and product, temperature, pressure. When you are changing any of these, the equilibrium is disturbed. The tendency of a reversible reaction is to attain equilibrium. So what does it do? It will behave in such a way so that again equilibrium is attained. Okay. So that means you are giving a stimulus, like if you are giving some stimulus or if you are giving some stress to the reversible reaction which is already in equilibrium. Why I am mentioning it as stress? Because equilibrium is disturbed. When equilibrium is disturbed, it undergoes a stress. So when you are disturbing it, it will behave in such a way that the disturbance is made zero. Okay. It will behave in such a way to counteract the disturbance. Okay, so that is what Lee-Chatellier's principle is. What does he say? Let us see that. States that change in any of the factors that determine equilibrium condition. Any of the factors means either concentration of reactant and product or temperature or pressure. of the system will cause the system to change. That means it will behave in such a way, such a manner, so as to reduce or counteract the effect of the change. So you brought some change so that equilibrium is disturbed. Now as the reversible reaction is having tendency to attain equilibrium, again it will behave in such a way to attain equilibrium, to regain its equilibrium. To come into equilibrium position, it will behave in. Understood? So that is what Le-Chatelier's principle is all about. Simple speaking, see, you can also define in such a way. If a system at equilibrium is subject to change in temperature or pressure or concentration, the equilibrium position is shifted to this side where the effect of change is nullified. That means the reversible reaction is behaving in such a way that the change brought should be made zero. The change brought should be made zero. So Le-Chatelier's principle is applicable for both physical as well as physical and chemical equilibria. It is applicable for both physical equilibrium as well as chemical equilibrium. So let us see how these factors are affecting the equilibrium and how the reversible reaction is counteracting the effects. Okay, first one is effect of concentration. Effect of concentration. When the concentration of any of the reactant or product in the reaction at equilibrium is changed. Already a reaction is at equilibrium. Now what you are doing? You are changing the concentration of reactant or the concentration of a product. On changing the concentration of reactant or product, the composition of the equilibrium mixture changes. That means it will be no long in equilibrium. That means its equilibrium state is disturbed, changes so as to minimize the effect of the concentration changes. That means it will behave in such a way to counteract or to make the change zero. Okay. Now for example, let us take A gives rise to B again. A is reactant and B is product. So now what will you write Kc for this? Kc is equal to concentration of the product by concentration of the reactant. What will you write Qc? Qc or Q, what is that? Reaction quotient. Quotient, this is also written as concentration of B by concentration of E, right? So when do you write Qc? When reaction is not in equilibrium. When reaction is not in equilibrium. Here, when do you write Kc? When the reversible reaction is in equilibrium. When the reaction is in equilibrium, you write. So now first it is in equilibrium. Now for example, you increased the concentration of reactant. Increased the concentration of reactant. That means A is increased. Concentration of A is increased, for example. When concentration of A is increased, what happens to Qc? Now QC is decreased. Why you are writing QC? Why you are not writing Kc? Because when you are changing the concentration of A, then the reaction will not be in equilibrium. Its equilibrium state is disturbed. That is the reason why I am writing QC. So when denominator is increased, automatically Q will be decreased. When denominator is increased, Q is decreased. Okay. Now what has happened? Now QC is less than KC. When QC is less than KC. When QC is less than KC, what happens? Whether the forward direction reaction, net forward direction reaction favors or net backward reaction favors? Kc is greater. Kc is greater means product is greater. Product has to convert into reactant. That means concentration of A is increased. When concentration of A is increased, Q will be decreased. When Q is decreased, what happens? Product concentration Kc is greater than Qc, right? Kc is greater than Qc. So now as Qc is less than Kc, so concentration A gives rise to B. So B by A. A is increased. A is increased. As A is increased, what must happen? A is increased. To attain equilibrium, A must decrease. If A has to decrease, then what should happen? The forward reaction must increase. So net forward reaction occurs. Okay. Already we have studied that when Kc is greater than Qc, net forward reaction occurs. So what see here, the forward reaction is favored by, forward reaction is favoring means what? See, you are writing, you are mentioning arrow towards right. Towards right means we say that equilibrium shifts towards right. See, no doubt about it, in a reversible reaction, both forward reaction as well as backward reaction occurs. No doubt. But if the rate of forward reaction is greater than rate of backward reaction, the net forward reaction occurs. How do we explain it? Both forward and backward reaction continues to take place. But the rate of forward reaction is greater than rate of backward reaction here. That means overall the net forward reaction is happening. The net forward reaction is happening means we say that equilibrium is shifting towards right. So here QC is less. That means concentration of B, see, you are increasing the concentration of A. Concentration of B is less than A. So concentration of B must increase. If concentration of B has to increase, why concentration of B has to increase? Because QC must be equal to Kc. Why QC must be equal to Kc? Because the tendency of a reversible reaction is to attain equilibrium. It has to attain equilibrium. If it has to attain equilibrium, the concentration of B must increase and concentration of A must decrease. If concentration of A must decrease and concentration of B must increase, then forward reaction has to happen. What has to happen? Forward reaction has to happen. So why we are discussing it in the terms of QC and KC means in the competitive examination, they will ask in the statement type questions in this format only. When you are increasing the concentration of reactant, what happens to Kc? Kc decreases. When Kc decreases, the tendency of a reversible reaction is that to attain equilibrium. So QC tries to equalize Kc. If Qc has to equalize Kc, that means Qc has to increase. If it has to increase, concentration of B must increase. So that concentration of A must decrease. Okay, so that the net forward reaction occurs. That means equilibrium shifts to right. Equilibrium shifts to right. The simple understanding is that when you add reactant, net forward reaction occurs. When you add product, net backward reaction occurs. The simple thing. Simply understanding. To remember. How to remember? If you add reactant, that reactant must decrease because you have added some reactant. When you added reactant, equilibrium is disturbed. That equilibrium, as equilibrium is disturbed, the added reactant must decrease. If added reactant has to decrease, it has to be converted into product. If it has to convert it into product, forward reaction is favoring. That means the rate of forward reaction is more than backward reaction. So overall you say the net forward reaction occurs. So net forward reaction occurring means equilibrium is shifting to right side. Okay. So equilibrium is shifting to right. So when does equilibrium shifts to right? When you increase the concentration of reactants, equilibrium shifts to right. Or decrease in the concentration of products. Decrease in the concentration of products. So the same thing if you take A gives rise to B, a reactant gives rise to product. QC, let us write QC. QC means B by A. If you decrease the concentration of products, you are decreasing the concentration of product. You are decreasing this. If you decrease this, automatically Q decreases. Now we say that Kc is less than Qc. If Kc is less than Qc, net forward reaction occurs. This already we have seen. QC is less than Kc. Net forward reaction occurs. Okay, net forward reaction occurs. Simply how to understand? So reactant gives rise to products. If product is decreased, there is some decrease in the product. So that decrease in the product has to be replaced. If it has to be replaced, what happens? Reactant must convert into product. If reactant has to convert into product, net forward reaction occurs. If net forward reaction occurs, we say that equilibrium is shifting to right. Equilibrium is shifting to right. Understood? Right? So, two things we need to remember. Forward reaction is favored by increase in the concentration of reactant, decrease in the concentration of the product. Backward reaction is favored by, that means the net backward reaction. Net backward reaction. So, let us see. For the reaction, A gives rise to B. QC is equal to increase in the concentration of product, B by A. The reaction which is at equilibrium, you are disturbing. How you are disturbing? By increasing the concentration of product, B. When you are increasing B, QC will be greater than Kc. If QC is greater than Kc, again it tries to attain equilibrium, what will be the net rate of the reaction? Net backward reaction. If net backward reaction occurs, we say that equilibrium is shifting to left. Equilibrium is shifting to left. Equilibrium is shifting to left. Are you getting this? Simple, how to simply understand reactant gives rise to product. You are increasing product. What you are doing? You are increasing product. If you are increasing product, the increased product has to get reduced. That is what Lee chart here say. If you bring a change, that change must be made zero. To make that change zero, this reversible reaction will behave in such a way to make the change zero. So now you made some change. That means you have added some product. That added product must be decreased. If it has to decrease, what happens? The product must be converted into a react. So the net backward reaction occurs so that the equilibrium is shifted to left. Simple thing. On adding product, net backward reaction occurs. That means equilibrium shifts to left. If you add reactant, the equilibrium shifts to right. Okay. Other thing, in another way also the equilibrium can be shifted to left. What is that? Decrease in the concentration of reactant. Decrease in the concentration of reactant. Reactant gives rise to product. Decrease the reactant. When you decrease the reactant, reactant is decreased, equilibrium is disturbed. So to attain equilibrium, some reactant has to be produced again. If it has to produce, what happens? The net backward reaction has to occur. Okay. So if you decrease the concentration of reactant, backward reaction occurs. If you increase the concentration of product, again to attain equilibrium, backward reaction occurs so that the equilibrium is shifted to left. Simple logic. Understood? So that is what. So it is explained in the terms of, you see, example. It is explained in the terms of example. See here, H2 gas plus I2 gas gives rise to 2HI gas. Okay. So already we have discussed that if you increase the concentration of H2 or I2, then what happens? Forward reaction occurs, net forward reaction occurs. See, this forward reaction, formation of HI is favored by increase in the concentration of H2 and I2. If you increase the concentration of H2, I2, what happens? As you have increased, that increased concentration must decrease, so forward reaction occurs. Or decrease in the concentration of HI. If you decrease the concentration of HI, that means some HI is removed from this vessel. If you remove this HI from the vessel, what happens? Some of HI is removed, that is to be replaced. If it has to be replaced, what happens? H2 and I2 must react and form HI, so forward reaction occurs. So either you decrease the concentration of HI or you increase the concentration of H2 or I2, then what happens? Forward reaction occurs. The net forward reaction occurs. Then we say that as the net forward reaction is happening, as it is happening in the right direction, so we say that the equilibrium is shifted to right. Understood? Okay. Next, let us see the backward reaction. Dissociation of HI is favored by increase in the concentration of HI. So H2 gas plus I2 gas gives rise to 2HI. Now if you decrease, if you add some HI, when you add some HI, equilibrium is disturbed. You have added some HI, that added HI must decrease. If added HI must decrease, then what should happen? HI should convert into H2 and I2. So what happens? Backward reaction occurs. The net backward reaction. Already I mentioned you, in a reversible reaction, both forward and backward reaction occurs. If one of the rate is more, then we say that it is net direction. Here the backward rate of backward reaction is greater than rate of forward reaction, so we say that the net direction is backward direction. So we say that as it is backward direction, means as we are moving it left, we say that the equilibrium is shifted to left. Okay. So on adding or increasing the concentration of HI, adding HI or decrease the concentration of H2 and I2. Let us take this H2 and I2 concentration is decreased. So sum of H2 and I2 is removed from the container. When you are removing it from container, equilibrium is disturbed. The removed H2 and I2 has to be replaced. If it has to be replaced, what should happen? Some of the HI must decompose to form H2 and I2. Understood? So again, in that situation also what happens? The backward reaction occurs. The backward reaction occurs. That means equilibrium is shifted to on the left side. Okay, let us see. Here another example. Ferric ion. What is this? Ferric ion. Thiocyanate. Thiocyanate. Ferric thiocyanate. Ferric, you can say that thiocyanate. So what do you say here? This is in equilibrium. This is completely equilibrium. That means if you see here, this is container aqueous. Okay. This is container. In this, what is present? Fe plus 3 is present. SCN minus is present. FeCN. Okay. FeSCN. FeSCN plus 2 is also present. All the three are present. This is in equilibrium, reversible reaction, right? Now, into this I am adding what? Oxalic acid. What I am adding? Oxalic acid. When I add oxalic acid into it, oxalic acid is H2C2O4. What is that? H2C2O4. The formula of oxalic acid is H2C2O4. So when you have added oxalic acid, this oxalic acid reacts with Fe plus 3. Fe plus 3 is reacting with H2C2O4, converting into FeC2. What is that? FeC2O4 taken thrice power minus. So product is formed. Okay, so when you add oxalic acid, this reaction already at equilibrium. So this reaction is at equilibrium. This reaction is at equilibrium. For a reaction at equilibrium, if you are adding this oxalic acid, what has happened? Sum of Fe plus 3 is decreased. What has happened? Sum of Fe plus 3 is decreased. Why they are decreased? Because when you are adding oxalic acid is reacting with Fe plus 3 and converting into a product. So Fe plus 3 is decreased. That means reactant is decreased. So when the reactant is decreased, what happens? To replace that decreased reactant, the product has to dissociate and convert into reactant. That means net what happens? Net forward reaction happens. See, the equilibrium shifts left. Why it is shifting left? Because you are removing some Fe plus 3. How you are removing this Fe plus 3? Because by adding oxalic acid, you are removing this Fe plus 3. When some Fe plus 3, when some reactant is decreased, then what happens? To reproduce that lost reactant, what happened? The product must dissociate to form the reactant. So when the product is dissociating to form the reactant, what we say? The net rate of backward reaction is happening, so that equilibrium is shifted to left. So in the question, you will be asked for this reaction which is at equilibrium, if you are adding oxalic acid, then the equilibrium is shifted to which direction? The equilibrium is shifted to which direction? Left direction, or the net backward reaction occurs. The same is here. You see, you are given, you are adding into this container, you are adding HgCl2. when you are adding HgCl2, it is reacting with thiocyanate ion and forming HgSCN4 taken -2. So when you add HgCl2 to the container in which there is equilibrium between reactants and products, now when you add HgCl2, it is reacting with reactant. What reactant? HCN minus reactant. When it is reactant, it is converted. So sum of the reactant is decreased. When the sum of reactant is decreased, when some amount of reactant is decreased, what happens? It is to be replaced. It is to be reproduced. If it has to be reproduced, what should happen? The product FeSCN plus 2, it should decompose and convert into reactant. So again, product converting into reactant means the net rate of backward reaction is more. If net rate of backward reaction is more, means automatically the equilibrium is shifted to reactant side. Equilibrium is shifted to reactant side. Understood? So this is about the concentration, how the change in the concentration of reactant or product makes the equilibrium position, shifts the equilibrium position. Okay. Next, let us see how does pressure affect this equilibrium state. No doubt about that pressure is one of the characteristics that determine the equilibrium position. Then if you change the pressure, automatically the equilibrium changes. Equilibrium get disturbed. So the reaction will not be in equilibrium. Again, it tries to attain equilibrium. In trying to attain equilibrium again, it will behave in such a way so that the effect brought is made zero. The effect brought is made zero. Right. Now, you have to remember that this pressure will affect the reactants or products which are in gaseous state only. If they are in liquid state or if they are in solid state, this pressure does not affect. This pressure does not affect. So now let us take a container here. Let us take a container in which some gas is enclosed by using a piston. Okay. Now initial pressure is Pi. So initial volume is V initial. Now if you increase pressure so that the piston moves down, Now final volume. So if you are increasing pressure, means P final is greater than P initial, so that V final will be less than V initial. Initial volume is more, final volume is less, right? So that means already we have studied that from Boyle's law at constant temperature, okay, volume is inversely proportional to pressure. This already we have studied. That means on increasing pressure, volume decreases. So for which type of reactions this pressure will show effect? For which type of reaction this pressure will disturb the equilibrium? When the reactants and products are in gaseous state. So only when there are reactants or products which are in gaseous state, and when their delta n is not equal to 0. What is that? When delta n is not equal to 0, then only it shows effect. on the equilibrium position. Okay, so let us see, increase in external pressure on the reaction at equilibrium favors the reaction in the direction in which volume or number of moles decreases. Volume or number of moles decreases. So here it is described in the by giving one example. What is that example? N2 plus 3H2 gives rise to 2NH3. What is delta N here? Delta N is equal to number of moles of gaseous products minus number of moles of gaseous reactants. That is equal to 2 minus here 1, here 3, 1 plus 3, 1 plus 3. That is equal to 2 minus 4. That is equal to minus 2. Okay, so this example is for this actually. This example is for here, well, delta N is equal to negative. This also delta N, let us see, delta N is equal to, right, NP minus NR, that is equal to here 1, here also 1, here 1, here 3. So that is equal to 2 minus 4, that is equal to minus 2. So these both examples are for what? If delta N is equal to negative. This is a different context. Okay, delta N is equal to negative. For this reaction, delta N is negative. For this reaction also, delta N negative. Let us take a reaction for which delta N is positive. Delta N is not equal to 0. First condition, let us take delta N is equal to positive. Positive, for example, let me take PCl5 gives rise to PCl3 plus Cl2. Okay, so for this, what is delta N? Delta N is equal to 1. What is that? 1. Here also 1. Here 1. So product constant Np minus Nr, that is equal to 1 plus 1 minus 1, that is equal to 2 minus 1, that is equal to 1. So delta N is equal to 1. For which reaction? PCl5. All are gases. All are what? In which state they are present? All are gases. So now in this container, what are present? What are present? PCl5 present, PCl3 present, Cl2 is also present. All are present. Now what I am doing? I am pushing it. I am increasing pressure. Increasing pressure. I am increasing pressure. If I increase pressure, how to remember? Simple. If I increase pressure, volume decreases. If I increase pressure, volume decreases. Here we say that 1 mole means 1 volume. Here 1 volume. Here 1 volume. So reactant side 1 volume, product side how many volumes? 2 volumes. If I increase pressure, volume decreases. So it should move in less volume side. It moves in less volume side. That means less volume side is in reactant side. So the net backward reaction happens. See, favors backward reaction. Net backward reaction happens. Simply understanding. Simply remembering, further remembering process. To remember, if you increase the pressure, for which reaction? When delta N is equal to positive, net backward reaction occurs. Net backward reaction occurring means equilibrium shifts to left side. Equilibrium shifts to left side. Okay. So the same reaction, let us take PCl5 gives rise to PCl3 plus Cl2. Okay, here what is that? 1 volume, 1 volume, here 1 volume, here 1 volume. 1 mole, we are taking 1 volume. Increase pressure, now decrease pressure. What we are saying? Decrease pressure. On decreasing pressure, what happens? Volume increases. On decreasing pressure, volume increases. If volume is increasing, then simply to remember, it should move. The equilibrium must shift to more volume side. More volume side is on product side. So simply it moves to more volume side. So you have to remember on which side more volume is present and on which side less volume is present. Less the number of moles, less volume. More the number of moles, more volume. Simple, understand in that way. If you increase pressure, volume decreases. So equilibrium shifts to less volume side. If you decrease pressure, volume increases. Equilibrium shifts to more volume side. That's it. That is what you need to remember here. If you want to understand in detail, again, this also let us see. When delta n is equal to negative, now we have seen that N2 plus 3H2 gives rise to 2NH3. Here 1 volume, 3 volumes, 2 volumes. Okay. Now already we have seen that delta n is negative. 2 minus 4, that is equal to minus 2. Increase pressure. Pressure increase. Volume decrease. So which side volume is less? Right side volume is less. So automatically the net reaction will be on the less volume side. Net reaction will be on the less volume side, or equilibrium is shifted to right side. This is the condition. Next condition is, if you decrease pressure, volume increases, inversely proportional. So more volume side is left side. So automatically the net rate of the reaction will be on the backward direction. So equilibrium is shifted to left side. See here, increase of pressure favors forward reaction. And decrease of pressure favors backward reaction. Decrease of pressure favors backward reaction. Simple understanding. Okay. Now let us see here. For the reaction, reactant gives rise to product. What will you write? QC, product concentration by reactant concentration. Okay. Product concentration by reactant concentration. Let us take this reaction. N2 plus 3H2 gives rise to 2NH3. So what will you write? Kp here. Kp is equal to, or Kc, let us write Kc, whatever you can write both to understand. Kc is equal to concentration of NH3 square by concentration of N2 and concentration of H2 whole. So if you increase pressure, for example, for this reaction, if pressure is increased, volume decreases. And we know that concentration is equal to number of moles by volume. If volume decreases, concentration increases. Is that? Volume decreases, automatically concentration increases. So if concentration increases, here there is only concentration into concentration. But in the denominator, if you see, concentration power 4, Kc is equal to, okay, concentration power square by concentration power 4 you are having, right? Okay, so now you are not writing Kc. What you are writing? You should write them as Qc. Why? Because on changing pressure, the reaction is not in equilibrium now. Not in equilibrium. That means this is increasing. Concentration, volume decreases. Pressure increases, volume decreases. When volume decreases, concentration increases. C means concentration. Concentration increases. If concentration increases, here in the denominator, concentration power 4 is there. So QC, what happens? QC decreases. What happens to QC? QC decreases. If QC is less than KC, if QC is less than KC, then we have studied that forward reaction is favored. That means equilibrium to right. So this is what is pressure increases, volume decreases, pressure increases, volume decreases, concentration increases. If concentration increases, QC decreases. QC decreasing means QC is less than KC. When this condition, when you obtain this condition, automatically we know that the forward reaction is favored. That means equilibrium shifts to right direction. So this is how in JEE mains level examination or NEET level examination the question can be asked. So in these factors affecting equilibrium constant, what type of questions can be asked? Theoretical type of questions can be asked. So that theoretical type of questions is asked correlating with this QC and KC. So that you have to understand. Okay, when pressure is increased, volume decreased, concentration increased. If concentration is increased in this condition, then QC is decreased. When QC is less than KC, automatically forward reaction favored. See, forward reaction is favored. The same can be applied for the next condition. Okay, so this is about the effect of pressure, and another is pressure does not show any marked effect on the equilibrium reactions taking place in solution phase. This is important, solution phase or in solid phase. So on the solution or solid, this pressure cannot show any effect. That is the reason why there will be no effect on the reactant and product which are in either in solid state or in liquid state. Okay. So that is about the effect of pressure and effect of concentration on the position of equilibrium. Hope so you understood very well. Thank you for watching. In the next class, we shall discuss the effect of temperature and effect of adding inert gas. Does catalyst affect or does not affect the equilibrium position? Right? See you again.